So we'll start by looking at a review question here. We'll look at a few domain questions. And remember we talked about domain in the last chapter, and we said that if we had a fraction, the domain came from looking at the denominator of the fraction. So we'd set that x minus 5 equal to 0. If we add 5 to both sides, we get x equals 5. So remember, our domain here is all real numbers, but x cannot be 5. We can write it in interval notation. Again, think of the number line. Here's 5, and we're crossing 5 out. So we would start with negative infinity and go to 5, and then skip 5, start right after 5, and go to infinity. So again, we'll look at the denominator, and we'll set the denominator equal to 0. There's a couple ways to solve this. I'll add 25 to both sides, and then I'm going to take the square root, but we need to take the positive and negative square root. So we get x is equal to 5 and x is equal to negative 5. So again, our domain is all real numbers, but x cannot be 5 and x cannot be negative 5. On an interval notation, we think of a number line. Here's negative 5, we need to x that one out, and here's 5, we need to x that out. So we want this section, and this section, and this section. So we'd have negative infinity to negative 5, and then negative 5 to 5, and then 5 to infinity. And we just put u's between the three sections. So we'll do one more domain problem. Here we have x squared plus 25 equals 0. I can subtract 25 from both sides. So x squared equals negative 25. Take the positive and negative square root of both sides, and I get x is equal to 5i, and x is equal to negative 5i. Now because of this I, we don't consider it as part of the domain or be having to exclude it because they're not real numbers. The square root of negative 25 is not real. So that means that the domain here is just all real numbers, or negative infinity to infinity. We don't need to exclude anything because there's no x values that will give a 0 in the denominator. So this arrow notation is a way of looking at a graph. And we'll talk about what this means more in the next few examples, but this is saying that x is getting close to some number, and the little plus sign means from the right. Here this x is saying x is getting close to some number, and the little minus sign after the number means from the left. And here this is saying x is going to infinity, and that means x is getting bigger and bigger and bigger. And x going to negative infinity means x is getting smaller and smaller and smaller. And when we talk about this, we're always looking for the y value that's happening on the graph as x is doing this. So let's see how that works. So in this first example, we're saying x is getting close to negative 3 from the left, and the left part comes from that little minus sign after. So x is getting close to negative 3 from the left. So we want to get closer and closer to negative 3 on the graph, but from the left side. So what's happening on that graph as we get closer and closer to negative 3 on the left? The y value is going down, and this is asking for the y value right here. The y is going down and down and down, which is negative infinity for y. So the next one says that we're going to approach negative 3, but from the right because of that plus sign. So this time I'm going this direction. And as I follow the graph headed that direction, the graph shoots up. So the y value would be going to positive infinity. So here this says I'm going to approach 1, and the little minus sign means from the left. So I'm coming from this side towards 1, and as I come from that side towards 1, the graph shoots down, which is negative infinity. And here, I'm going to approach 1 from the right. So I'm coming in from this side, and as I do, I follow the graph, and it goes up, which would be positive infinity. So these last ones, now we're saying x is going towards negative infinity. So that means I'm going out further and further and further out this direction on the x-axis. So as I follow the graph further and further out that direction, what's the y value getting close to? Well, the y value is getting close to 0 because that's what the x-axis is. X-axis is the y value of 0. We do the same sort of thing on the right here. It says as x goes to infinity. So now we're talking about x getting bigger and bigger and bigger. So we follow the graph out that direction, and it's getting closer and closer to the x-axis, which is y equals 0. A vertical asymptote is like a magnetic wall. It draws the graph closer to it, but the graph can't touch or cross that vertical asymptote. We draw them as dashed lines. And the way we find them is when the denominator of the fraction equals 0. So here we'll find the vertical asymptote. We're going to take the bottom, we'll factor, or I can say x squared minus 1 equals 0. Let's go ahead and factor it up here, because in future problems we're going to need to factor. So remember, this is a difference of squares, and as a difference of squares it factors as x plus 1 and x minus 1. So now instead of doing it like the whole thing equal to 0, let's set each factor equal to 0. So this is a vertical asymptote, and this is a vertical asymptote. They're both vertical asymptotes. So we have to be careful when we write things, because when we write domain, we want to write all real numbers except that x cannot be these numbers. But when we write asymptotes, we aren't writing all of that. We're just writing x is equal to 1 and x is equal to negative 1. And these would be dashed lines on the graph. And we'll look at that in a little bit later. So here's another example. It's the same denominator, but the numerator is different. So let's factor the denominator. And here's why factoring becomes important, because the top and the bottom have the same factor on it. So this fraction reduces to 1 over x plus 1. That's important with the vertical asymptote, because now we just take that x plus 1 and set it equal to 0. And this graph actually just has one vertical asymptote at negative 1. So in this example, we look at it, and the denominator is x squared plus 1. And x squared plus 1 does not factor because of the plus sign. It's a sum of squares, and it doesn't break down. So there's nothing we can do to break that apart. And you'll see that if we start trying to solve this to set it equal to 0, we get x squared is equal to negative 1. And if we take the square root of both sides, we get plus or minus I. And again, we only want real answers, so we don't consider that. So this has no vertical asymptotes. So let's talk about horizontal asymptotes. Horizontal asymptotes depend on the degree of the top and the bottom. And we're really talking about what happens on the outside edges as x goes to infinity or negative infinity. If the degree on the top, n is the numerator, degree of the numerator, and m is the degree of the denominator. So this is saying the degree on the top is smaller than the degree on the bottom. If that happens, then the vertical or the horizontal asymptote is automatically y equals 0. If the degrees are the same, then we use leading coefficients, and we'll have a over b. And if the degree on the top is bigger, then we do not have a horizontal asymptote. So let's look at this one. The degree on the top is 2, and the degree on the bottom is 2. So because they're the same, we use the leading coefficients. We say y is equal to 9 over 3, and the 9 over 3 can reduce, and so we left with y equals 3. Here the degree on the top is 1, and the degree on the bottom is 2. Because the degree on the top is smaller, it's automatically y equals 0 for the horizontal asymptote. Here the degree on the top is 3, and the degree on the bottom is 2. Because the degree on the top is bigger, then there is no horizontal asymptote.